Hello guys, today we're going to talk about dot and cross product. The dot product is basically just if you have A as a vector which has component x1, y1, z1, and B has x2, y2, z2. The dot product is basically just timing x1, x2 plus y1, y2, and plus z1, z2. If you're going to higher dimensions, then you have like something like w1, w2 plus this and this, kind of like that, I guess. Now there's a property for this, which is a dot b is a b cosine theta, and this is the magnitude or how small or large the value is. So for example, if we take the vector 3 and 4, which means x is 3 and the y is 4, we have the magnitude to be, using Pythagorean theorem, we have 3 squared plus 4 squared to the square root is equal to 5. It's kind of like this. So basically finding the magnitude is x1, y1, z1 is equal to x1 squared plus y1 squared plus z1 squared. And the way we prove this is using something called law of cosine. Yes, it is called law of cosine, which is just saying that if you have this and this and this, and the angle between them is theta, then you have c squared plus a squared plus b squared minus 2ab cosine theta. You basically have this. Okay, now we're going to move on and prove this. So now we have, this is x1, y1, this one is x2, y2, and this vector using the vector addition. So this is a plus this is equal to b. So this is equal to b minus a, which is equal to x2 minus x1 and y2 minus y1. And now we have the magnitude of b minus a squared is equal to magnitude of b squared plus magnitude of a squared minus 2 magnitude of b a magnitude of b cosine. So this term is going to be expanded out and get x2 minus x1 squared plus y2 minus y1 squared is equal to x1 squared plus y1 squared plus x2 squared plus y2 squared is equal to 2 square root of this, which is x1 squared plus y1 squared x2 squared plus y2 squared cosine. And this is going to be square plus x1 x2 plus x1 plus y2 minus y1 y2 plus y2 squared. This is going to cancel out pretty nicely, and this cancels out, leaving it to be 2 x1 x2 and minus 2 y1. Wait, is that correct? Yes, it is correct. Y2 this is going to be -2, x1, y1, x2, y2, cosine. So cancel out the -2. We have this is going to be the dot product of A and B, and this is going to be the magnitude of A times magnitude of B, cosine theta. So now we prove this theorem. This is pretty nice, and I don't see like the normal textbook prove this, so it's pretty nice. So dot product, the definition of dot product is taking this x or A cross with B is equal to this. I'll explain in a second. Bx, by, bz. The way you evaluate it is it is equal to this a1 az by bz minus y ax az bx bz plus c ax ay bx by. And what do I mean by this? X hat, y hat, and z hat. It is just indicating the direction of a vector. And with magnitude of 1. So this term is equal to 1, 0, 0. And this is equal to 0, 1, 0. And this one is equal to 0, 0, 1. So what do I mean by this term? This term, it is called determinant. And the way you evaluate determinant is by finding this. For example, just taking A, B, C, D. The determinant of this is it is going to be A, D minus B, C. And it's pretty nice, you know. And now, let me erase this. Oh my god. Just wait a second. And this is going to be x ay az by bz, or just write it out. The way you evaluate it is you see the first term and just ignore these terms and just get this one out, and for the second term you put a negative first. Then you like ignore this and this, and ignore this one, just taking this 2 out, and put a negative sign over here. So it's ax az bx bz. And for the third term, you're just ignoring this and this. So and there's a plus sign, and it is ax ay bx by. So this is equal to x ay bz az by minus y blah blah blah. I'm just too lazy, I don't want to do this. Okay. And the cross product of vectors is also a vector, you know, because it has directions and magnitude. And the geometric mean, or the how do I say this? Just the geometric meaning of dot product is just finding the area of the parallelogram. It's just finding this, the area of this. Now we're going to prove this. So we can expand out and find the area of the blue part, is this part, and the area of the green part is going to be this, and the yellow part is going to be this, and the red part is going to be this. And the area of the large rectangle is going to be this. And now we just minus the color area to the large rectangle, then we can get the area of the parallelogram. So because the vectors are all in 2D, the way we evaluate this is this: yz, x1, y1, because there's no z, just put 0, x2, y2, 0, and this is equal to x1, y2 is x2, y1. We can see that when all the colors plus each other is going to be x1, y1 plus x2, y2, x1, y1, x2, y2, and wait, let me see, x1, y2 plus y1, x1. And by expanding out, we have, yes, x1, y1 plus x2, y2 plus x2, y2 plus x1, y2, and this is difficult. Yeah, I don't care about this anymore. Just if you find the correct error, and you will get this. And now we're going to talk about the direction of the cross product. The direction of the cross product is perpendicular to both vectors, meaning that it is making 90° with both of the vectors. So the direction is just by, I'll show you this. Here, this is vector A, and there is vector B. And if you let your palm facing the direction of A and bend your fingers towards the direction of B, and this is right hand. The direction of the vector or C, you call it C, is the direction of your thumb. Okay, is the direction of the thumb. And there are many applications with the dot or the cross product in finding such as torque and finding, I just think is finding torque. Just tau is equal to RF, and there's O and there's R and F. We're gonna talk about it later, And now we're going to do the derivative of the vectors. There are some properties. So dr dt is basically equal to, by its definition, is going to be r plus dt minus r t divided by dt. Let's limit dt approaching 0. So this is basically the way you evaluate this. And if, just take example, r is equal to f t g t and gamma t, by separating out the values, you can get that it is equal to ft dt plus ft times the x component plus gt dt minus gt component plus blah blah blah, and this is basically equal to ft times the direction of x plus gt times the direction of y and gamma t and the direction of z. This is the way you find the value of this. And we're going to take a look at this type of function. So this one is a scalar and this one is a vector. So the way we do this is just also using the form or the definition t plus dt f t plus dt minus yt f t divided by dt, and this is t dt f t plus dt. And this, like, we also learn it we also learn it like when do we learn this? I think, oh yes, in the first lesson. And this is dt. And separate out, this is basically evaluating the derivative of phi times f, and this one is basically finding the derivative of df dt and times the scalar t. And similarly, we can evaluate if it is all vectors, the dot, and then similarly we can get this, it's very similar. And for the case of this, it's also very similar. So this term is equal to f dt dot g plus f dot dg dt, and this one is going to be this plus f as dg. Notice that a cross b is not equal to b cross a, because the direction is opposite, so this one must be equal to the negative of b cross a. So what I mean is that if you take a vector a and then take a vector b, and you use your palm facing that way and your fingers, as this is the right hand, the direction is going to be this way. And if you're finding b cross a, it's going to be this and this, which is going to be this, and your sum is going to face that way, which is the opposite way. And now we're done with this lesson.